I would like to invite Mr. Shobhit Sharma, who is the Senior Client Partner at Solulever. Please welcome Mr. Shobhit with a huge round of applause.
So, good afternoon, everyone. My name is Shobhit Sharma on behalf of Solulever, and today I'm going to share something that's transforming the chemical manufacturing industry. Before I begin, I want to share a conversation that truly crystallized the challenges we are facing. Last month, I was speaking with the plant head of a specialty chemical manufacturing. Picture this. We were in his office overlooking a state-of-art manufacturing plant with the advanced reactors, top-tier chemical manufacturing, decade of process knowledge, yet looking at his plant performance and dashboard, he told me something profound. Shobhit, we have millions invested in advanced chemistry, but when it comes to sustainability and efficiency, we are still operating like it's last century. Can someone resonate with it? This disconnect between our advanced manufacturing capabilities and our basic approach to sustainability and efficiency, this is where both our challenge and our opportunity lies. Let me start with a question worth billions. How much is energy inefficiency costing your operation today? Through our work in multivariate manufacturing across specialty chemicals, petrochemicals, and fine chemicals, we have uncovered striking patterns. Let me break this into three critical areas. First, energy efficiency in batch process. Typical batch operation wastes 25 to 35% energy during heating and cooling cycles. For a medium-sized specialty chemicals, that's often 4 to 5 crore annually, summing up $350K to $500K annually. Why? Because most plants still focus on fixed heating and cooling profiles, regardless of batch size and ambient processes. Secondly, the reactor utilization. Despite high market demand, average reactor utilization hover around 65%. Think about that. Most expensive assets are idle 35% of the time. What are the causes? Extended cleaning cycles due to lack of predictive tools. Quality hold time waiting for lab results. Suboptimal batch scheduling. Reactive maintenance intervention. The third but not the least comes the quality deviations. Our data shows quality-related issues cost specialty chemical manufacturer 12 to 15% in rework and wastes. Whether we call it as paint industry, specialty chemical industries, or surfactant industries. But it's not just material cost, it's a cascade effect. The cascade effect on energy consumed in reprocessing, lost production time, additional quality testing, delayed rundown, deliveries, complete batch losses is the worst case, where the batch got NCIP or not fit for sale. What's the cost of not adapting? Let's dive deeper into what's really at stake for process and batch manufacturer today. The industry faces unique challenge that makes this transformation urgent. Energy, the environmental impact, consider this. A typical chemical manufacturing plant uses enough energy to power 10,000 houses daily. That's not just an environmental issue, it's a massive cost center that's becoming increasingly expensive every day. Let me share a real example. One of our clients, a polymer manufacturer, was spending $12 billion annually on energy alone. They thought this is just the cost of being into the business or doing the business. But when we analyzed their operation, we found reactor heating cycles running longer than necessary, which is directly impacting their energy cost. Cooling water systems operate inefficiently. Nobody was watching the efficiency of the cooling system or the cooling towers, which adds on to the energy cost. Steam traps. Steam traps is the least discussion which happens into our industry, which adds to the energy consumptions daily to our production. For example, if you are producing 10,000 tons daily, so imagine what a CPP, a captive power plant working on inefficient steam traps, would cost you. Unnecessary idle equipment running. If the scheduling of batches are not idle, it will gonna create unnecessary idle equipment, and the reactive maintenance adds to it. What are the financial risks on it? The financial impact extends beyond energy. Consider raw material pricing have increased 40% in 2 years. Regulatory compliances cost 15% annually. Carbon taxes are become reality. The strict guidelines from the CPP is a nightmare for specialty chemicals and chemical manufacturers. Now, let's examine what's really happening on the plant floor. In chemical manufacturing operation, inefficiencies have a compounding effect. Let me explain. Multiple reaction stages, critical temperature profile, precise catalyst addition, strict quality parameters, complex cleaning procedures. Here's what we typically see in a chemical manufacturing. The batch process challenge. Imagine you are running a critical surfactant manufacturing. Your temperature log shows you are within a limit. Your control system, you are having a state-of-art control system. You have best APC, you have best DCS on your shop floor. Imagine the temperature logs are showing within specification. Our pressure readings are normal, and your raw material additions are on schedule. Yet, the final yield is lower than expected. Why? We did this one POC with one of our client, and we discovered something very fascinating using the Bravo. While their control system showed stable temperature, our pattern detection revealed micro variation in jacket temperatures. This jacket temperature micro variation were too small for the traditional systems to create a flag, because for the traditional system, it was in the limit. But the slight deviation was creating the yield to be lower than expected. And this is not only impacting the yield, this is impacting the catalyst efficiency and ultimately the yield. Quality integration gap, let me share a real example from a specialty chemicals. Their situation looked perfect on paper. Lab tests showing 98% purity, all process parameters within limit, batch records fully compliant, yet they were facing increased customer complaints about product inconsistency. When we integrated Bravo platform, we discovered micro deviation in temperature, control during critical parameter, subtle catalyst degradation pattern, hidden correlation between raw material and variations, and final quality. Now coming to the production losses. In specialty chemical, hidden losses are particularly costly because they often go undetected until it's too late. Let's break down what we call as invisible losses. Speed loss, think about your reaction completion time. Most plants determine the endpoint by fixed time, or basically analytical measurements. But here's what we found at a fine chemical manufacturer, suboptimal reaction rate costing 2 to 3 hours per batch. Cleaning cycle extends by 40% due to lack of real-time cleanness verification. Cleanness cycle extended by 40% due to lack of real-time cleanness verification. Quality clearance delays adding 12 to 15% of batch time. The yield loss. These are particularly painful in high-value chemical manufacturing. Incomplete reaction due to missed optimization opportunities. Off-spec material from process variation. Conversion efficiency drops from equipment degradation. A specialty chemical manufacturer was achieving 92% of the yield on a high-value product. They consider this as industry standard. After implementing Bravo, real-time optimization, they discovered optimal temperature profile could vary batch to batch. It is not to be fixed for across the grades. Catalyst activity had a wider sweet spot than assumed. Real-time endpoint detections could improve yield. Their result, yield improvement to 96%, that is a 4% efficiency gain in yield, which was costing $2.8 million annually. So this is the saving which we did. This is where the Bravo intelligence unleashed comes in. We have built a platform especially for the complexities of chemical manufacturing. Real-time process integration, our system provides millisecond monitoring of critical parameters, AI-driven predictive quality modeling, advanced energy optimization algorithms, AI-driven analytics. The platform delivers real-time reaction endpoint predictions, yield optimizations, predictive maintenance alerts. Critical modern chemical manufacturing, detailed carbon footprint tracking could be done through the platform. Resource usage optimization. This is one of the client example which I was stating you is this one, the largest carbon black manufacturer and how the raw materials are going waste due to inefficiencies. Let me share another transformative story that brings this all together. One of our clients, a leading specialty chemical manufacturer, faced challenge you might recognize. Rising energy cost, quality inconsistencies, increasing regulatory pressures, sustainability demand from customer. After implementing Bravo, they have achieved 30% energy reduction in batch processes, 20% increase in reactor utilization, 15% improvement in first pass yield, RFT, which we call. ROI in just 12 months. So these are the ROI which I was stating, the cost saving, revenue growth, and competitive advantage. And these are the client profile which was stating the scalability and future integrations, embracing sustainability and optimizing further. In the closing, I would say the manufacturing industry stands at a critical juncture. The question isn't whether to transform, it's how quickly you can adapt to stay competitive. The Bravo offers you, oh, sorry, I guess I missed it. What Bravo offers you is 90 days rapid deployment over your shop floor, industry-specific solution, comprehensive support, and proven ROI methodology. If you are interested, let's schedule assessment of your operation roles whenever you are comfortable. And thank you for your attentions. I'm happy to take your questions, if any, and we are available on the booth also if you want to learn more about Bravo. Thank you. Any questions?
Great, great. Thank you so much. Do we have any questions for sir? I guess we don't have, sir. Thank you so much for your time.